Okay, welcome back for some more fun with math. In this lecture, we are going to talk about simplifying and evaluating different algebraic expressions and what that means. Well, before we actually get into the math, you have to kind of understand some of the terminology that gets used when dealing with expressions. First and foremost, we have a term. Now, a term is going to be any constant. It can be a variable. It can be a variable power. Or it can be the product of a constant and variable together. So, what does that mean? Well, it means, for example, it could be something like the number 5, or maybe we're talking about the letter A. We could be talking about something like x cubed, so variable power, or we could be talking about something like 15b, or even as simple as 3y to the fourth. Anything like that, those are all considered terms. When we talk about a constant, we are talking about a single number. In other words, things like 3. Okay. A coefficient would be the number next to a variable. So if we had the number 4x squared, my coefficient would be the number 4. That would be the coefficient. A variable is going to be any letter. In other words, A, B, C, etc., all the way down to X, Y, Z. So we have 26 letters that you can choose from. Now, when we talk about like terms, we are talking about those that have the same constants or terms. So they have to be identical, meaning they would have to be the same number, or they would have to be the same variable, or they have to be the same variable power. Okay. So here we just want to go ahead and identify some like terms. So notice everything is all scrambled up. And so I have a 2x squared. And when I look around, I'm looking for another x squared term. Okay, so if I'm looking down the row, notice here is another x squared term. Therefore, my like terms are going to be negative 2x squared and 7x squared. Okay, the coefficients do not have to be the same, but the variable term itself does. Now the next thing I have is I have this straight number 5, and if I look down, I also have a straight 1/4. So another pair of matching terms would be 5 and negative 1/4. Notice they're both constants. And then I have this 5x cubed. Well, there's no other x cubes, so the final result I have is this 15x cubed. Now, if you notice, as I was doing these, I was putting different symbols underneath my terms. I personally do that to help keep myself straight. It is not something that you would have to do. But for me, I've always found it to be the easiest way for identifying my terms that are the same. Okay, so again, for example, I have this 3xy squared. If I look down the rest, none of them are that. So my first term is 3xy squared. Now I have this negative 10a squared b. So what I am looking for again is I am looking for another a squared b part. So here I have an ab, here I have ab squared, here I have an ab, here I have a squared b. So this would be my second term, or my other like term. So I have negative 10a squared b, and I have 12a squared b. The next thing I have is this ab part, and here's my second ab part. So I have 8ab and 5ab. The last thing that I have is I have negative ab squared. So negative ab squared. And those would be my like terms. So notice, I'm not looking at the coefficients, I am looking at the variable counterparts to be the same. Another way that you have to be able to identify your like terms is you have to be able to look at an expression, so given the term 5x minus 12, and you have to be able to answer questions about it. So questions in the form, is the first term a variable term or a constant term? So to know that, we have to know what does first term mean and what does second term or so on mean. The first term, or the beginning of your expression, is called the first term. And then the next one that comes after it is called the second term. And so on and so forth all the way down. So when we're talking about the first term and we want to know if it's a variable term or a constant term, well, remember, a variable term means has letters. So what we're really asking is, does the first term have letters? That is what we're asking. And in this case, yes, it does. That first term is 5x, so yes, it's a variable term. Now, the next question says, is the second term a variable term or a constant term? So again, we're asking the same question. Does the second term have letters? Well, the second term would be a negative 12. So that would be no letters. So it is a constant. Being able to identify your different types of terms becomes very important, especially the more advanced you get in math. Now, the biggest thing we do with terms is we have to combine them. So combine them says that we are looking for terms that are the same. Once you identify them, well, in order to remove any parentheses, you always have to remember that you have to complete all operations inside your parentheses. Once you do that, you can combine the coefficients and leave the variables the same. Okay? So let's look at what all that means. So first, we have to look for terms that are the same. So I have a negative 3x and a 7x. So these terms are the same. I don't have any parentheses, so I don't have to worry about removing them. So this essentially means I'm going to combine the coefficients. So I have a negative 3 plus a 7, and I'm going to keep the variable the same. Well, negative 3 plus 7 is a 4, and I'm going to keep the variable the same. So essentially what you need to remember is that the variable is along for the ride. Okay, it stays the same. Looking at this second one, I have a 5x and I have an x and I have this 8 in the middle. So what I always like to do is I like to write my terms next to each other. So 5x minus x minus 8. And this part right here is the part that will combine. So I actually have this negative here. Well, this negative means negative 1. So if I'm looking at combining my coefficients, I really have 5 minus 1, keep my variable the same, and then minus the 8. 5 minus 1 is 4, and minus 8 is along for the ride. So let's keep going. In this third one, notice I have a parentheses. So the first thing I have to do is get rid of it. I need to do what's called distribute through it in order to drop it down. So my 2 comes through, and this becomes a 2n minus 8 plus n plus 1. So in doing that, again, I'm going to put my like terms next to each other. So this is going to be a 2n plus an n minus 8 plus 1. My 2 coefficients will combine here. And just like before, this right here is actually going to mean plus 1. So I actually have 2 plus 1 n, and then I have negative 8 plus 1. So this is the second part that gets combined. So negative 8 plus 1 is a negative 7. 2 plus 1 is 3. So this whole thing becomes a 3n minus 7. In this next one, notice I've got 2 sets of parentheses. So again, I have to distribute, but I need to distribute through both. Distributing through the first is fairly simple. My sign out here is positive, so 3 times 2 will give you 6. Remember, your x is along for the ride. And then 3 times 1 is plus 3y. On this back, we have this negative here that we have to remember. So it has to flow through the back parentheses. Negative 2 times x is a minus 2x. Negative 2 times negative y makes it positive. Negative and negative is positive, and then it's 2y. Again, I want to group my stuff together, so I have this 6x and negative 2x. I then have this 3y and positive 2y. So I have 6x minus 2x plus my 3y plus my 2y. Again, when I look at this term right here, I actually have 6 minus 2 with my x along for the ride, and then I need to combine this side. So this is going to be plus 3 plus 2 with a y along for the ride. 6 minus 2 is a 4x. 3 plus 2 means plus 5y. Now it looks like these didn't print the way I wanted. This should have been 3x squared, and this should have been a 12x squared. So I have 3x squared plus 4xy minus 5xy minus 12x squared. So I'm going to rearrange my equation so that my like terms are next to each other. I have a 3x squared minus a 12x squared plus a 4xy minus a 5xy. Again, this is my first terms together, this is my second terms together. So this is going to be the same as 3 minus 12, and that x squared is along for the ride. I'm adding that to 4 minus 5. And my variable here is going to be x, y. 3 minus 12 is going to be negative 9x squared. 4 minus 5 is a negative 1x, y. Thus is your solution. Now with this one I have a fraction, and so in order to combine fractions you need to follow your fraction rules, which state that you have to have common denominators. Well, in order to get them you have to remember that this is the same as saying n over 1. So what's common between 1 and 4? Well, that's going to be 4. So in order to turn a 1 into 4 means I have to multiply. So this is going to become 4n over 4 minus 3n plus 5n over 4. Well, I can actually write this with the single denominator. So this is really going to be 4n minus, and now I need to input a parentheses because this negative here, this one, has to apply to both. So I'm going to put a parentheses here and do 3n plus my 5n, which is going to remind me that I have to take care of that negative sign. So this is going to be 4n minus 3n minus 5n. And my whole thing is over 4. So I really have 4 minus 3 minus 5. So that's what I'm working with. So 4 minus 3 minus 5 n, and the whole thing is over 4. So when I look at that, I'm going to go ahead and bring it up here. 4 minus 3 is 1, minus 5 is a negative 4 n over 4. My 4 over 4 cancels and is going to leave me with a negative n, and that is my combined result. Last, we have this one over here. Again, I have 5 as my denominator. So if I remember, this is going to be the same as over 1. I have to multiply top and bottom by 5. So this is going to become 2y plus 4y all over 5 minus 10y over 5. I can put the whole thing over a single denominator. So this is going to be a 2y plus 4y minus 10y. I can combine my coefficients. So this is 2 plus 4 minus 10 y. The whole thing is over 5. 2 plus 4 is going to be 6 minus 10 gives you a negative 4 y over 5. Now, the last really big thing that we have is being able to evaluate. Evaluate essentially means substitute. So in order to evaluate, you have to be able to substitute given values in for your variables. And then you just have to simplify by following your order of operations. So before we get to that, we need to do a little mini refresher on what it means if you have a negative sign and you're dealing with a power. If your term is completely encased in parentheses, then your power here not only applies to the number, but it applies to the power, or the sign as well. So this would be the same as saying negative 5 times a negative 5. Negative times negative is positive. 5 times 5 is a 25. However, if you don't have a parenthesis, then this power here only applies to the number, and then the negative is along for the ride. So this is the same as saying that I have a negative of 5 times 5. Well, 5 times 5 is 25, and then apply the negative and get a negative 25. The other approach that we have is being asked to evaluate, and then you're told that you have terms for your variables. So here we're telling you that we want you to simplify the expressions at hand and then plug in the different values we have for the different variables. So the first thing I need to do is group my terms together. So I have x minus a 3x minus 10 plus 2. So this is going to be the same as 1 minus 3x minus 8, because negative 10 plus 2 is negative 8. One minus 3 is going to be a negative 2x minus 8. And if you notice here, the only variable I have is an x. And I'm telling you that x is 4. So this is going to be negative 2 times, and in this case I'm telling you x is 4. So I have negative 2 times 4, which is a negative 8 minus 8, gives you a negative 16. And that is how you evaluate. So let's go ahead and look at a couple more examples. I have to distribute my 4 through my parentheses, and then I got to distribute the 5. Distributing 4 says this becomes a 4y plus 12, and then I have plus 5y minus 10. Again, I got to combine my like terms. So I have a 4y plus a 5y plus 12 minus 10. And now the other way that you could approach this, instead of simplifying and combining all the way down is at this point you could go ahead and plug in for your variable. So the second way we could do this is that we know that y equals something, and here it just means that I'm going to have to multiply twice. It also means I'm going to be working with bigger numbers. So whether you reduce it all the way down so you only have to plug in the once, or you plug in at the beginning and keep going, you're going to arrive at the same conclusion. So here I have 4 times a negative 3, which is a negative 12. 5 times a negative 3 is a negative 15. Then I have plus 12 minus 10. Well, notice I have a negative 12 and a plus 12, so those essentially are going to go away. Negative 15 minus 10 is a negative 25. Now you could check yourself by plugging your term in up here way at the beginning and seeing if you get it, or solving this all the way down by combining like terms before plugging in. But regardless of how you approach it, you'll end up with the same result. So let's look at a few others. I'm going to go ahead and do it this way so that we can remember what my terms were. So here I have a 5a and a 3a, and then this was ab squared, and this is 2ab squared. So I'm going to combine my terms. 5a plus 3a plus ab squared minus 2ab squared. I always find it easy to combine all the way first and then plug my values in, so I'm going to go ahead and do just that. I'm going to combine these two together, so this is going to be 5 plus 3a, and then I'm going to add this to 1 minus 2ab squared. 5 plus 3 is going to be 8a. 1 minus 2 is a negative 1, so negative ab squared. Now I can plug things in. I know that a is negative 2 and b is 7, so this is 8 times a negative 2 minus a negative 2 times 7 squared. So here I've got a negative 16. Minus a negative is going to become positive, and then this is going to be 2 times 49. So when I'm looking at it, 2 times 49 is going to give me 98. So this is negative 16 plus 98. So 98 minus 16 is going to give me an 82, and that is the overall result I'm looking for. Now, if I look over at this next one, notice I not only have a bracket, but I have a parenthesis. So in order to actually work this out, you need to start from the inside out. So that says I have to distribute my 5. So I've got my 5x on the outside minus 2 times x plus 5x minus 15. I then have to combine my terms from the inside. So this is a 5x minus 2, and then on the inside I have x plus 5x, which gives me 6x minus 15. I now have to distribute through my parentheses again. So this is a 5x. Negative 2 times a 6x is a negative 12x. Negative 2 times a negative 15 is a positive 30. Now I've got my two like terms out in the front. So again, this is going to be 5 minus 12x plus 30. 5 minus 12 is going to be a negative 7x plus my 30. And in this case, my x is 4. So this is negative 7 times 4 plus my 30. Negative 7 times 4 is negative 28 plus 30, which gives me 2. Now the last thing I have is this fraction here, and so remember we need to have a common denominator or the lowest common denominator. And the easy way to get there is to take your two denominators, so 3 and 7, and multiply them together, which gives you 21. Therefore, how do I turn 3 into 21? Well, I multiply by 7. So this is going to be 7 times negative 4b plus 10b over 21. And then this is going to be plus, and then I had a 7 on the bottom, so it's going to be 3 times a negative 2b minus 5b all over 21. So I can write this as a single fraction over 21, and I have to distribute through my two parentheses. So 7 times a negative 4 is a negative 28b. 7 times 10 is plus 70b. 3 times a negative 2 is a negative 6b. 3 times negative 5 is minus 15b. So along my numerator I have negative 28 plus 70 minus 6 minus 15. So all told, that is going to give me 21b over 21, which is going to reduce down to b. Well, what do we know? We know that b is 7. So that means this is going to give me 7 as a result. So that's kind of everything that you need to know about being able to simplify and work with algebraic expressions kind of down at their core. If you have any questions, please make sure you let me know. Otherwise, as always, remember, math is bananas. So keep smiling, ask tons of questions, be sure to have lots of fun with your math, enjoy what you're doing, and as always, see you next time.